And just to keep in practice, a technician recently drilled a hole in a hair, his way of demonstrating the type of minute operation without which the manufacture of really accurate small timepieces would be impossible. People, machines, and metals. There's accuracy in metals too. Take, for example, the hairspring of America's fine watch. Here is the beating heart, pulsing 5 times each second, controlling the operation of the balance wheel and determining the accuracy of the watch. Although it is called a hairspring, it is sometimes only 1/5 as thick as a human hair. And because of its small size and the job it has to do, it must be as nearly perfect as human skill can make it. In this steel mill, materials are weighed to split fractions of an ounce on scales that can weigh an eyelash, can weigh a fingerprint. In the making of metal for this hairspring, it takes careful control of the ingredients and careful control of the heat and a lot of patience and know-how. The exclusive alloy known as Elenvar Extra is produced by this miniature steel mill in 10-pound ingots, only 2 pounds of which are actually used. Without Elenvar Extra, the amazing and record-shattering performance of Hamilton marine chronometers and other wartime pieces would never have been achieved. It is now used in all watches made by this company. When you are making the finest hairsprings in the world, you watch that raw material like an incubator baby. A half-ton a year total output and only 25 pounds of that usable. Steel alloy, much more precious than gold, ounce for ounce, when it's made into hairsprings. A pound of Elenvar Extra hairsprings would be worth nearly $1 million. Although it does its part to make a fine watch fine, finished alloy is only a raw material. Before it can be used, it must be fabricated, shaped to its purpose. So the ingot is forged into a rod. The rod is turned and swedged, beaten and stretched, and then processed and extended to 60,000 times its original length. From a 20-inch rod, 20 miles of mirror-finished ribbon, finer than a hair, produced from start to finish under exacting laboratory conditions for quality control. But there's still more to it than that. The flattened ribbon of wire is precisely coiled, permanently set by heat into its final spiral shape, and then through incredibly delicate operations installed on the balance assembly. Did we say that the hairspring is the heart of time? Did we say that the accuracy of a really fine watch is determined to a large degree by the accuracy of its tiny hairspring and balance wheel? Only in this factory will you see this machine, an amazing electronic vibrator, a machine that measures with microscopic precision the exact length of hairspring needed to make the completed watch a really accurate fine watch. By testing no more than the hairspring and balance wheel with no other gears, springs, nor any of the other vital watch parts, this machine can yet tell with almost absolute precision how fast or slow a watch will run before it is assembled. In 1769, when James Watt patented his first steam engine, he was proud of his manufacturing accuracy, as demonstrated by the fact that certain parts of the engine were machined to tolerances of 1/10 of an inch. Today, parts that go into a really fine watch are made to tolerances as small as 1/10,000th of an inch, some even to 1/100,000th of an inch, and instruments are used that can measure 1/1,000,000th of an inch. To make fine American watches, special precision measuring instruments, gauges, and tests had to be developed. Measurement and remeasurement, inspection and reinspection, check and double check. Fine watchmaking is the ritual of accuracy and the worship of precision. Of the 2,000 operations which go into the making of a fine watch, nearly half are inspections, and 20% of these are double inspections, or inspectors inspecting inspectors. A speck of dust and 40 pounds of bread dough. What has this to do with watchmaking? A great deal, it seems, when you realize that every morning this amount of bread dough is mixed and used throughout the factory to remove specks of dust, chips and filings from small parts which have just been machined. Bread? Then how about honey to go with it? Ordinary honey is used to hold tiny jewels together during the manufacturing operation. Jewels, those tiny bits of extremely hard and precious stone, rubies and sapphires synthetically produced, which serve as bearings for moving parts. These bearings are so frictionless, movement so effortless, that a fine watch could be kept running for 4,000 years on the power used in lighting a 25-watt light bulb for 1 hour. To reduce friction in the vital parts, all fine watches have 17 or more jewels. This is the minimum number. More jewels can be used in watches, but it is important to understand that 17 or more jewels do not necessarily make a watch fine. That the measure of a good watch lies not alone in the number of jewels it may have, but in the attention that is given to every detail in the design, planning, manufacture, finishing, and assembly of every part that goes into a watch. Friction is the bugaboo of all machinery. In a fine watch, it is avoided like the plague. Oil is a friction fighter. So the watch oil, to fight friction and prevent wear, must be the finest of the fine. Here in miniature scale is a complete oil refinery producing what is probably the world's finest watch oil. A single flask like this is enough to lubricate 500,000 watches, and yet most of this precious lubricant, which costs about $6,000 a gallon, is thrown away because it is delivered drop by drop to the watch assemblers. Then it is kept clean and fresh by a delivery schedule in which every 2 hours the leftovers are carefully wiped away and replaced. It takes nearly 9 months to complete the 2,000 operations that go into the making of a really fine watch, but it takes nearly 2 years from the time a new watch movement is conceived to the delivery of the first production unit. During this time, more than 100,000 man-hours of design, careful engineering, and specialized skills go into the development of the new movement and the precision tools and equipment needed to build it. Here are watches that were never made. That is, after time and money went into their development, they were never put into production because they didn't measure up to the standards which make America's fine watch. To make a fine watch fine takes many laboratories. Laboratories for testing old and new materials. Laboratories for the control of quality. Laboratories where heat and extreme cold answer critical questions, where metals are twisted and torn apart. Laboratories where the answers to scientific problems are found on machines and measuring instruments that can see the invisible or can weigh a pencil mark. Laboratories where the highest development of nearly every science known to man plays a part in the production of a really fine watch. And research is an endless task. Almost since the beginning of time, man has been asking the question, what time is it? Here the question is, what time really is it? Imagine building a timepiece so accurate, so faithful in its measurement of time that nowhere in the world was there a machine precise enough to check its error. This is what happened when the famous Hamilton marine chronometer was produced for our Navy during the war. To check this chronometer, built in mass production in defiance of watchmaking tradition, the electronic comparator was developed for the Naval Observatory to show variations measured in 1/200th of a second. And the time microscope, forerunner of all rapid timing devices used today, is so precise that it reduces measurements which used to take days to less than half a minute. This magic lantern, the time projector, helps check the accuracy of tiny watches which have no second hands, enlarging the minute hand on a screen so that otherwise imperceptible movements can be accurately measured. Yes, it takes some of the world's most precise scientific measuring instruments to make sure that a fine watch is really fine. With the work of many hands, American production methods are making it possible for people in all walks of life to own fine watches. American craftsmanship with American men and women, with the wisdom of experience working alongside the eager spirit of American youth, with patience and skill and pioneering enthusiasm, all these produce the finest watches that human ingenuity can design. You can